Okay, good morning, class. So, at this point in our lives, we're busy with exponents. I think this is the last lesson on exponents. Okay. And we're busy with scientific notation. Not so. We're wrapping that topic up. The homework was exercise 4 on page 18. Alright. You late, Michael? Okay. So, scientific notation. Page 18, number 1. Write in scientific notation. Okay, so you must mark your work now. Just let me know if you have any issues here. Okay. So what we're going to do is I'm going to do the whole exercise. The reason being, when we did the explanation of the sums, you guys were a bit skeptical on it, or when you are right and not exactly confused. What to do at certain points, okay? So what I'm going to do is I'm going to do the whole exercise for your benefit. Okay? So if you don't understand, you just stop me, and then we will take it from there. Okay? So the question says, write in scientific notation. So currently the comma is lying after the 5. Not so? So it must move 1, 2, 3, 4, 5, 6. So it must move 6 units. So it's going to be 3, 7, 2, 8, 9, 3, 5 times 10 to the positive or negative 6? Positive 6. Okay. Let's look at the next one. As you can see, the comma is lying at that point. Not so? It's not lying as it always lies at the back. The comma is given there. So there must be one significant figure in front of the comma, which is 1 in this case. So I'm going to move it 1, 2 units. Can you see that before? So it's going to be 1,73, 529 times 10 to the 2. Okay. As you can see, the comma is lying currently there. So in this case, the comma is moving from left to right. So it's going to have a negative exponent in this case. All okay with that? So how many units is it moving? 3, 4, 5. Comma is going to lie. Do I need the zeros in front of the comma? How many zeros do you need? You only need 1. No, you don't even need a 1. Why? Because the significant figure there is 6. So how many units are we moving it? So it's going to be 6,05 times 10 to the negative 5. Alright, as you can see, the comma is lying here now. That's all. So I'm going to move it 1, 2, 3 units. So that's going to give you 7,832 times 10 to the negative. You all okay with that? Any? Yes. If you write the zeros before the 7.
No, also. We still do the 9.
Yeah, but the 2.
Now putting my 3 by the 6. With the 5.
And you put zeros here.
Yeah.
You'll get it right, but it doesn't have any place value. Okay. Any other confusion? No? I'm going to keep the instruction in focus there, so I'll take this off. Salam. Did you fill the bottle, Kaname? Okay. Alright, 1.5. So as you can see, where's the comma line now? After 0. Not so? So it's going to move 3, 6, 7 units. Do you see that, people? So that's going to give you 8,75 times 10 to the 7. As you can see, the comma is lying here now. So it's going to move after the 6. So it's 1, 2, 3 units. That will simply be 6, 0, which is 6, times 10 to the negative 3. The comma is currently lying there now. Okay? Yeah, she took my bottle. I don't know if she broke that one yet.
She said that's my bottle. The one is broken out. Where's the other bottle?
Next one.
What's the other?
Yeah. The see-through bottle. Okay. So you're going to move it. 3, 6, 7, 8. Can you see that? So that's going to simply be 3,45 times 10 to the 8. Are you all okay with this? Right? And then the last one, 1.8. Comma is currently lying here. It will lie after the 1. So it's 1, 2 units. So it's going to be 1,580023 times 10 squared. Okay. Any confusion, people? Huh? No, no confusion. Alright, can I move on? Yes? So now we're looking at number 2. I'll just bring this down. Page 18, number 2, page 18. In number 2, we are told to write these as ordinary numbers. Let's write these as ordinary numbers. Okay. I'm going to do 2.1 and 2.41 there. Okay. So that's the way I cut it. It made sense at the time. Alright, so as you can see, it's 10 to the 4. So the comma must move in that direction. 4 units. Okay. So if I take the comma into account there, and I move it 4, it's 1, 2, 3, so what am I shorting? The 0 there. Can you see that? So then it will be written like it. You all agree with that? So that is going to be 8,515. You all okay with that? The next time the comma is lying there. So you got 10 to the negative 2. So the comma must move to the left, from right to left. So if I move it 2 units, I'm moving it 1, so what am I shorting? 0, 0. Not so. So that's 1, 2 units. So that answer is going to be 0, I don't need that 0, 0.763. Okay, any confusion there? No? .2 and 2.5 will do together. So the comma is currently lying here. So in which direction must the comma move with a negative exponent? Left. It has to move to the left. So I need a couple of zeros here. Not so. So how many units must I move it? 5. So it's going to be 1, 2, 3, 4, 5. You all agree with that? Oops. In other words, I still need 1 0 there, not so. I need 1 0. So it's going to be 0, 1, 2, 3, 4, 6, 1, 2. Can you see that, people? So I can count 5 there. It's 1, 2, 3, 4, 5. Yes, that's correct. Does it make sense? People, this work is not going to stick if you're not going to practice it. Majority of the work in maths works like it. Okay? If you're not going to practice the work, you're not going to remember how to do it. Okay?
Mr. Bodin?
Yes, miss?
I'm looking for Priyanka Mugande. Is she with you?
She is, miss?
Can you send her to the office quickly, sir?
No problem, miss. You know where the office is, my girl? Hmm? But you guys understand? Right. Let's look at the next one. So this comma is going to move to the right or left?
Left.
Left. How many units going to move to the left? 1. So it's moving at 1. So that's simply 0,843. The last one is 2.3. Is this comma going to move from left to right? Right. How many units going to move to the right? 6. So just add zeros there. So I'm going to move it 1, 2, 3, 4, 5, 6. I don't need those two. So that's going to simply be 3, 2, 0, 6, 000. And there we go. Does it make sense, people? Okay. So let's move on. Page 18. Now we're looking at page 18. The question says simplify without using a calculator. Again, I'm going to do 3.1 and 3.4 together since it's stuck together. Okay. So, as I said, there's one of two ways of doing this. When it was okay. Alright, so there's one of two ways to do it when we multiply. Okay? One of two ways. I can just do the straight multiplication, which is going to be the better form when we multiply and divide. Okay? So this here, we're going to multiply those bases together. When you're multiplying and bases the same, what do you do to the exponents? We add it. So that will simply be 10 to the exponent 7. But this here will be 3,6 multiplied by 2. Not so. It's 3,6 multiplied by 2. That's going to give you 2.5, carry 1, that's 6, 7. How many digits after the comma? 1, so it's going to be 1. So that's 7,2 times 10 to the 7. Okay? Any confusion there? No. Okay, let's look at the next one. So 3.4. Looking at 3.4. When we're adding and or subtracting, okay, and it's exponential numbers, the exponent has to be the same. With a variable, if we're adding subtracting, the variable must be the same. Not so. Now we will consider 10 to the exponent negative 4 as the variable. Okay? So what can we do here if the exponents are the same? We can just simply say that's going to be 10 to the negative 4, and I can add 4,2 and 5,1. Does it make sense? This is like saying 4,2x plus 5,1x. And I can just add this. 4.2 plus 5.1 is going to be 9.3x. Not so. Likewise, in x's place, what do I have in x's place? 10 to the negative 4. So 4.2 plus 5.1 is going to be 9.3. Is that in scientific notation? Yes. Why? There's one significant figure in front of the comma. You all understand?
Yes.
Okay. Go to the next one. 3.2. 3.5. Okay. So 3.2 we multiply. So when we're multiplying it bases are the same, what do we do with the exponents? We add them. So that and that bases are the same. So in other words, I'm going to multiply 2,34 multiplied by 5. 5 times 4 is 20, carry 2. 5 times 3 is 15 plus 2 is 17. Carry 1. It's going to be 10 plus 1 is 11. How many digits is after the comma? 2. So the comma lies there. You all agree with that? So it's going to be 11 comma 7. Do I need that 0? Why not? Does not contain or does not have a place value. Okay. So we multiply here. When we're multiplying and bases are the same, we add the exponents. So is 10 to the negative 12 plus 7 is 10 to the negative. What's negative 12 plus 7? Negative 5. Is this in the proper scientific notation? No. Why? There must be one digit in front of the comma. Here the comma is currently here. So one digit would be there. Not so? So that's going to be 1,17 times 10 to the, how many units did I move that comma by? 1. So is that going to be minus 1 or plus 1? Plus 1. So that's moving from right to left. So when you multiply and bases are the same, you add the exponents. So that is 10 to the 1 times 10 to the negative 5 is 10 to the negative. Yes, Michael? 3.1. But if you look at 3.1, is that not already one digit in front of the comma? No. You see, the question was 3.6 times 2. So that was 72 years. But there's one digit in front of the comma. So it's 7.2 and not 72. You understand, Michael? Nice. Anybody else that's confused? Huh? No? Just ask, no? Don't be shy. To ask. Alright, 3.5. When we're adding, subtracting, what must be the same? The 10 to the negative 2. Is it the same? So do I have to change it? No. No changes need to be done here. Okay? So then in fact, then that will still just be 10 to the minus 2. So in other words, we're going to say 7,23, which is that number, plus 6,9. If that had to be minus, I would have said minus 6,9. Are you all okay with that? Hello? Okay, I'm coming now. Is it if it's a charger quickly? I forgot the charger. Sorry about that. So it's going to be 7,23 plus 6,9. Remember, when we're adding or subtracting, we must make sure that the numbers are falling in line. Not so. And the guide is what? A comma will be our guide. Not so. So let's add. You see here? There's no digit there. I can put a 0. Or in my mind, I can add a 0. So 3 plus 0 is? 3. 2 plus 9 is? 11, carry 1. 7 plus 6 is? 30 plus 1 is? 40. And in line with that comma it will be. Okay? So that is going to be 14,13. Is that in the right scientific notation? No. So how many units must that comma move by? 1. We move from the 1 from there to. Not so. So in other words, that's going to be 1,413 times 10 to the. How many units am I moving it? 1 times 10 to the minus 2. So what value now? You multiply and bases are the same way? Add the exponent. So that's going to be 1,413 times 10 to the. Okay. Yes?
Sir, for 3.5, sir, why didn't you add 10 to negative 2 or 3 to negative 2?
You see, if that was 7,23, she's asking why I didn't add these two together, okay? So it's 7,23 x plus 6,9 x. If that was the sum, what would the answer have been? 7,23 plus 6,9 is 14,13 x. Not so. So what do you notice? That the variables stay the same when you're adding and subtracting. So you see how adding and subtracting here? So that has to stay the same. Same like this here, staying the same. That is also staying the same. Only when you're adding and subtracting. When do we add the exponents or when do the exponents change? Exponents change either when you multiply or divide. That's the time the exponents change. Does it make sense?
Yes, sir.
Alright. Let's do the last one. On page 18, 3.6. Oops. Okay. So the question again is a multiplication question. So when you multiply and the bases are the same, what do you do to the exponents? You add. So it's 10 to the 8 plus 10 to the 7 will give you 10 to the 15. Not so. But that's going to be 1,6 times 3. 3 times 6 is 18, carry 1. 3 times 1 is 3 plus 1 is 4. How many digits are after the comma? 1. So the comma goes. So it's 4,8 times 10 to the 5th. Okay, any issues there? No? Sorry? Okay. Is that the last of it? Okay. So that brings us to the end of the section. If you have a problem, please rewatch the video. This should sort out your issues. Okay.